morning. I am Devasena. In this lecture, we are going to discuss about biopotential electrodes. In detail, we are going to discuss about polarizable electrodes, non-polarizable electrodes, and half-cell potential. Bioelectrodes. Here is a representation how the electrodes are fitted over the skin and how the biosignals have been picked up from the skin. The human body generates electrical signals on the body surface. Recording electrodes pick the bioelectric events produced in the body. The picked up signals are then given to the amplifier and then to display. Electrodes transfer ionic conduction in the tissue to the electronic conduction in order to measure the values. Generally, there are two types of electrodes, namely surface electrodes and needle electrodes. A surface electrode picks the potential difference from the tissue surface without damaging the live tissue. Deep electrode indicates the electric potential value from inside the cell. The difference between the potential at zero current and the measured potentials while current is passing is known as the overvoltage and is the result of an alteration in the charge distribution in the solution in contact with the electrodes or the ion selective membrane. This effect is known as polarization and can result in diminished electrode performance, especially under conditions of motion. There are three basic components to the polarization over potential: the ohmic, the concentration, and the activation over potentials. Perfectly polarizable electrodes pass a current between the electrode and the electrolytic solution by changing the charge distribution within the solution near the electrode. Thus, no actual current crosses the electrode-electrolyte interface. Electrodes made from noble metals such as platinum are often highly polarizable. A charge distribution different from that of the bulk electrolytic solution is found in the solution close to the electrode surface. Such a distribution can create serious limitations when movement is present and the measurement involves low frequency or even DC signals. Non-polarized electrodes, however, allow the current to pass freely across the electrode-electrolyte interface without changing the charge distribution in the electrolytic solution adjacent to the electrode. If the electrode moves with respect to the electrolytic solution, the charge distribution in the solution adjacent to the electrode surface will change, and this will induce a voltage change in the electrode that will appear as motion artifact in the measurement. Thus, for most biomedical measurements, non-polarizable electrodes are preferred to those that are polarizable. The silver chloride electrode is one of that has characteristics similar to a perfectly non-polarizable electrode and is practical for use in many biomedical applications. Let us see the characteristics of biopotential electrodes. Electric potential generated in the body are ionic potential. The transducers convert the ionic current in the body into an electronic current that flows through the electrode. It conducts small current across the interface between body and measuring circuit. A net volume of current passes across the interface from the electrode to electrolyte. At the electrode-electrolyte interface, current flows from left to right. The electrode has metal atoms, namely C. The electrolyte has cations of the electrode metal, that is C plus, and anions A minus. During oxidation, the atoms lose the electrons. During reduction, the atoms gain electrons. Half cell potential. Half cell potential is the voltage developed at the electrode-electrolyte interface. In a metal solution interface, electrode potential arises at two conditions. That is, first one, when ions travel from metal into the solution, and when ions in the solution combine with the electrons in the metal, they form the atom of the metal. When ions travel from metal into the solution, electrode potential arises. Here is the representation. When ions in solution combine with the electrons in the metal, they form the atom of metal. Due to this also, electrode potential arises. Here is the representation for that. When semi-permeable membrane separates two different ionic solutions of two different concentrations, an electric potential appears across the membrane. Motion attribute. When the electrode moves with respect to the electrolyte, the distribution of the double layer of charge on polarizable electrode interface changes. This changes the half cell potential temporarily. If a pair of electrodes is in an electrolyte and one moves with respect to other, a potential difference appears across the electrodes known as motion attribute. This is a source of noise and interference in biopotential measurements. Motion attribute is minimal for non-polarizable electrodes. Thank you very much for listening this lecture. If you like this lecture means, kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.